Hello everyone. Today I want to briefly touch on how to figure out the scale when you're drawing a graph. I've gotten enough questions now where I figure I might as well just make a video on it. Alright, so first off, you want to look at your data, and if we look here, what is my largest value? It is 80 centimeters per second. Again, these are just made up numbers. This is not what your values should look like, but it is 80 centimeters per second. Once you have that largest value, you want to ask yourself, okay, well, what can I do to use as much of my graph as possible? And in order to do that, you're going to have to figure out what scale would be applicable for these numbers. Now, here I've drawn a graph, and we have 14 lines on your y-axis and 14 delineations on your x. Now, in order to determine your scale, you should take that largest value, and you should divide that by the number of lines. So we have 80 centimeters per second divided by 14 lines, and this gives us 5.714 centimeters per second per line. Now clearly we're not going to go up by 5.714. That would be way too awkward to do. Now I would recommend here that you round this number up, and I would say probably round it to 6. Now I noticed a lot of you, when you were rounding your numbers, you actually rounded down. Why can you not round down? Say if I rounded this to 5.5. Why can't I do that? Well, if I round to 5.5, then I would not be including my largest value on my graph. Think about it. If I go up by 5.714, when I get to my top line here, that will be exactly 80 centimeters per second. Right? So going up by anything less than this number would not allow us to fit our maximum value on our graph. So I would use 6. Right? 6 will allow us to use the majority of our graph. Now, what about my other axes? What about the x-axis? Well, here we have a time of 0.5 seconds as our largest value. And again, I have 14 delineations. So how am I going to figure that out? Well, same strategy. 0.5 seconds divided by 14 lines gives us 0.0357 seconds per line. Now again, that is a super awkward number. We should not go up by 0.0357 seconds per line. In fact, if we look, our times are every 0.1 second. So we want to pick a scale that allows us to hit 0.1, 0.2, 0.3, 0.4, 0.5. Here, I would say the best option is 0.05 seconds per line. So that means every second line would be 0.1, right? 0.2, 0.3, 0.4, 0.5. Now, this doesn't exactly allow us to use our whole graph, but this is the best option given our values. Now, if I were to plot our data, here I've given you perfectly linear data, right? But let's look at a different example. Let's say I had a graph. When I plotted my points out, it looked like this. Okay, it looked like this. Now, another area I noticed some of you were struggling in is line of best fit. So how am I going to draw a line of best fit that makes sense for these values? I've noticed a lot of students are doing something like this. They'll pick 2 points and they'll connect the dots, right? Something that looks like this. Would that be an accurate representation of your values? No, clearly not, right? This is not an accurate trend describing your data. What about if you did something like, I'm seeing some students do something like this where they're going through 0, 0. Right? Your graph doesn't necessarily have to go through 0, 0. Right? If your trend is not through 0, 0, you don't necessarily have to go through it. For this example, what I've drawn here, you want to make sure that you have an equal area above and below the line. So if I have my line of best fit, I would probably draw it something like this. Now, that's not perfect. I probably should lower this line a little bit, but you want to look and you want to see, okay, well, how much area do I have above the line? And is that approximately equal to my area below the line? Here you can see that I probably have too much area below the line. So if anything, I should probably lower this line of best fit just a little bit. So let's do that. That's slightly better. All right, so that's the basic premise behind the line of best fit. Right? You want to try to have an equal area above and below the lines, above and below the line, and you want to make sure that it does show an accurate trend of your data. Right? It doesn't necessarily have to go through 0, 0, and you want to make sure you use this line when calculating your velocity on a position time graph. And for calculating your acceleration on a velocity time graph. And to do that, you want to choose 2 points on your graph, 2 points on your line that will line up nicely with your x and your y, and use those to calculate the slope of your line, because your slope is your acceleration.